Hello, welcome to MCAD's Tech Days 2015. My name is Chris Dubuque. I'm an application engineer out of the Beaverton, Oregon office. And this presentation, I'm going to cover the $6 million part. How to rebuild it faster, stronger, and smarter. So the SolidWorks portfolio is very, very broad. Today, we're just going to focus on the design aspect, working just with SolidWorks itself. So what am I talking about here when I mention rebuild it faster, stronger, and smarter? What am I really going to cover? Well, primarily I'm going to talk about configurations, whether we create them manually, we create them through different types of tables, equations, as well as global variables. So the gist of my presentation is taking a part that maybe isn't the best example of modeling in SolidWorks, but changing it into something that could be much, much better. So I'm going to start with a little bit of review. What are configurations? It's functionality in SolidWorks that allows us to show multiple versions of a design within a single part file, typically through feature suppression, turning features on and off, as well as dimensional changes. So a dimension could be evaluated with different numerical values in different configurations. So what I have here is a very simple part with three different configurations: vertical slots, no slots, and kind of angled slots, as well as the feature manager tree. And I just want to emphasize that configurations, once again, a single part file. So what we can see here is the tree screenshot for the top configuration with the vertical slots. Notice cut, extrude 4 and 5, they're grayed out. That means they're suppressed. SolidWorks is not calculating them. If we switch to the next screenshot of the tree, this is the middle version with no slots at all. Notice most of the tree is suppressed, only unsuppressed and being evaluated as boss extrude 6 and cut extrude 1. And finally, we unsuppress cut extrude 5, which gives us the angled slots. So the bulk of the geometry is the same. We're just turning features on and off to give us the vertical slots or no slots or angled slots, for example. Okay, so we have this functionality in SolidWorks. Why would we want to use it? Well, one reason is design reuse. Because it's the same file, it makes it very easy to create a family of very similar components. As well as we've got less files to manage. Instead of having to rebuild the part over and over and over, or doing a file save as and having lots of parts to deal with, we've got one model, contains all the geometries, and we can really modify our configurations accordingly. Maybe you're just looking to optimize some performance. You could set up a performance configuration that suppresses features that are increasing your rebuild time. Maybe lots of fillets or a pattern or something along those lines. You want to represent manufacturing operations, configurations can do that as well. One configuration for a forged versus rough machining versus final machining. And the different configurations show these various aspects of the manufacturing process. Another example is something I use quite a bit: simulation-specific configurations, suppressing, I call them unnecessary features here, but they could be cosmetic features, small fillets, maybe engraved text, for example, or just simply features that don't contribute to the structural integrity of the part. Suppressing features that could be difficult to mesh. There's a lot of different reasons to use them on the simulation side. I'm sure there's many more reasons to use configurations than the 4 I've listed here. These are just a few I thought of off the top of my head. Now, because we're working with with one model file, not everybody can use configurations. If you've got a lot of very, very unique parts, or everything's a one-off, maybe configurations isn't the best SolidWorks functionality for you. So what can you control with a configuration? Well, when I started working with SolidWorks, you could only change dimensional values and you can only suppress and unsuppress features. But now you can see that list is quite expanded. We can configure materials and relations and in conditions of features, what sketch plane you're sketching on. Colors, properties, even equations and global variables are now something that is configurable inside of SolidWorks. The top three, though, those are still the most commonly used. That's what I see more than anything else. suppressing features, changing dimensional values, as well as configuring your materials. So finally, how do we do this? Well, we can create them manually using the configuration manager tree in SolidWorks. We can use a configuration table, and we can get there from configure feature, configure dimension. Or if we really want to get into it and build many, maybe hundreds of configurations and program the part, well, then we could use an Excel design table. It does require a separate license of Excel, and design tables do not work with any other spreadsheet program. So, I'm not going to go into design table functionality. It's something else that's out there, but because it requires something other than SolidWorks, I don't see it used that much anymore. So let's jump into SolidWorks and let's take a look at maybe not the best modeled SolidWorks part. So let's start off by going through the tree. So here we can see we've got a revolve boss there to begin everything, and a separate extruded boss for a hub, as well as a separate draft feature. Something I've called the bolt pad, and a hole attached to it, and then a pattern for the bolt pads and the bolt holes. A separate slot, you can see that little curved slot geometry, as well as a pattern for the slot. The spline is a library feature, not really going to do anything with it here, and then a number of fillets. We'll just shift select all those fillets. So you can see there's a whole bunch of fillets that are down at the very end of this part. So let's start creating some configurations, and I'm going to start with the configuration manager. All parts and assemblies have this default configuration, even if you don't ever add an additional configuration. It's just how the software functions. We can right click on the part file name, say add configurations, and go ahead and give it a name. I'm going to create a simplified version with no fillets, so I'll just call it no fillets. The description is an optional field, so are the comments. But if you define a description and you select use in bill of materials, SolidWorks will automatically populate that for you. And speaking of the bill of materials, there are unique options or specific options for a part with configurations. Do you want all the parts to show the, or all the configurations, excuse me, to show the document name? Or maybe each configuration to be itemized by its configuration name? Or if none of those work, you can itemize them based on a user specified name. So we do have some flexibility when it comes to the BOM options. I'll just set it back to the document name and we'll say OK. And now I have a no fillets configuration. This manual method is going to take us back to the feature manager tree. And for this first example, I'm just going to shift select all the fillets and in the pop-up toolbar say suppress. Now this suppression, because I've created the no fillets configuration, is going to be unique to it. So there we can see no fillets is active, double click on the default, all the fillets come back into the part. So very easily we can switch between a simple version with no fillets and a more complex version with all the fillets. And that's really all there is to it. We just continue that process whether we're making dimensional changes or we're suppressing and unsuppressing more fillets, or excuse me, more features. Let's make a configuration so we can change the number of holes. And we're going to be utilizing this bolt dimension, or this bolt pattern dimension, this D1 at 6, or the 6 at D1 right there. Now before I actually make the dimensional change, let's add the configuration with a right click. You can kind of see where I'm going here. I'll call this one 4 holes. Switch back to the tree and then change this dimension. And we do it the same way. We double click on the feature we want to change, we double click on the dimension we want to change. But we need to pay very close attention to this pop-out window right here, because every dimension will start on the all configuration settings. There's no global option to change this in SolidWorks, so be very careful. Make sure you change it to this configuration and then key in the dimensional change, because if you don't, this change will go through all my configurations and could cause some problems. So we rebuild, and there we can see the number of bolt pads and bolt holes changes to 4. Double click back on default or no fillets, and it changes to 6. So once again, pretty easy to do. Changing features, suppressing, unsuppressing them, or we're going through and making dimensional changes. But now I need to create several more configurations, and I don't want to go through the tree, add the name, back to the manager tree, and back and forth. So let's look at a different technique. And I call this using configuration tables. The way we get to it, once again, if you want to configure a feature, right-click, configure feature. Or if you want to configure a dimension, right-click on the dimension and say configure dimension. And this will show the 3 existing configuration that this part has and give me options to create new configuration. We'll create one called 5 holes, 6, and 7 holes. Basically, as fast as I can type, I generate new configurations through this interface. So it's very, very efficient. And then just key in new dimensional values. We'll say 5, 6, and 7. If I want to save this table so I can get back to it, just give it a name. I'll call it holes and hit the little save icon. If you don't save a table view, once you OK out of this, this table is, I'll say, gone forever. If there are other features you want to add to this table, just jump back over to the tree, double click on a feature, for example, and there we can see various checkboxes to suppress and unsuppress that feature. Double click on other dimensional values, and there we can see those other dimensions get populated in there. If we want to remove them, just right click and delete them. So very flexible. I'll save it, we'll say OK, and now I'm going to have 4 holes, 5 holes, so on and so forth. So you can see creating these configurations, it really doesn't take very much time. But all I've done is change a few dimensions. I've suppressed and unsuppressed some features, the fillets. There we can see between the default and the no fillets version. Let's go back over to the tree and let's talk about the material, because configuring the material is something that's very, very useful. We can do that in a similar fashion. Right click, configure material, and this will get us into a very similar window, and this will give us a drop-down list to our material favorites. If you don't have the material in your favorites, we can see browse for more and just simply pick the material you want. Let's say this configuration will be 6061. The 5 holes configuration, maybe we'll make it 4340. We'll close that, and let's go to the 6 holes configuration. We'll make it titanium. You can see similar interface. We get into our material library, and we can go ahead and configure anything and everything of this part. I'll leave 7 holes default and no holes. I'll leave them as is. So we'll test the part, and we can see 4 holes to 5 holes. We're now at 4340. We go to 6 holes. We're at 64 titanium. So I think we have a pretty good grasp on configurations. But I want to point out, this part doesn't really do what I want it to do. Notice when we go to the 4 holes, we still have 6 slots. So to recap on the configurations, we built a simple version with no fillets. We've got various configurations to control the number of holes. Few of the configurations have different materials, but the part doesn't rebuild correctly. The number of slots doesn't follow the number of holes, and that's why this part really isn't the best that it could be. I wasn't thinking about design intent and automation when I created it. It's kind of a hodgepodge of a model. So now we can start looking at configurations, and I think of SolidWorks configurations as beginning automation. They are basic math functions using dimensions. They're always in the form of the dependent variable, an equal symbol, the independent variable, and the formula, the expression, any constants you want to use, any other functions, sine, cosine, trigonometric functions of the like. We can set up global variables for equality statements. And they are order dependent. They are solved sequentially from top to bottom. Why is this important, you might be wondering? Well, that's because the dependent variable or the result of one equation could be the input or the independent variable of another equation. So that dependent variable needs to be calculated first before SolidWorks can use it for an equation later on down the line. So it is important to keep your equations in the appropriate order. We can add equations through the equation window, a dimension modification box, a property manager, just by using the equal symbol. Basically anywhere you would normally type in a dimension, like an extruded boss depth, or typing in a dimension or a number for a dimension. If you hit the equal symbol, you're in equation writing mode. And finally, if statements, Visual Basic if statements are supported. You can use them to drive suppressing a feature or different dimensional values a dimension is controlled by. So you can get some pretty interesting functions just using native SolidWorks equations. They, like configurations, have really come a long ways over the last few releases of SolidWorks. So back over to our part. And our goal is to basically make this part do what I want it to do. I want everything to automatically update. I don't want to have different values of holes versus slots. I created all the fillets separately. And these are a whole bunch of different fillets. Well, maybe they should all be the same radius. So let's start taking a look at equations and make this part update a little bit better. So equations are located under the Tools pull-down menu. And I'm going to start things off with a couple global variables. So we'll just say one for the fillets, tabbing over to the next, and we'll say 1.5 millimeters. Any comments are optional, and I could continue this process and add more and more global variables. But right now, let's go down to equations, and let's find one of these fillets right there. So I select on it, and there we can see a dimensional value. We grab the dimensional value in the window, the code for that dimension pops up, we get the equal symbol, and we can attach it to our new fillets global variable. We could say OK, and that is calculated and stored within the model, and there we can see our global variable. But I did say OK, which exited me out of that equation window. Well, I don't need to be in the equation window to add equations. I could go to fillet number 7, double click on it to show the dimension, find the dimension I want to control, double click on that, and just hit equals. That'll get us into the exact same equation functionality. Now I'm not going to link every single fillet here, but we can see that it changed. Let's grab this one right here. So currently it's 1 equal symbol, global variable 1.5, rebuild. And I can continue this process throughout the model. So the idea here is not to scrap what I've done, but to take what I've done, use some equations, use some configurations to get it to be a more automated, more robust model. So we've got some global variables in there, and we could keep working with that. But let's talk about these configurations here. The 4 holes, the 5 holes, the 6 holes. This just doesn't work. So let's create an equation that's going to tie the number of instances created by the slot pattern to the number of instances in the bolt pattern. Now, one thing that I like to do when working with equations, if I'm going to create a number of equations, is I just show all the feature dimensions. So you can see right-click annotation, show feature dimensions. Now, you might have more dimensions than you really want to see, so you can go to individual features and either right-click and show them or right-click and hide them. But some of these dimensions I'm just going to ignore. Another thing that you'll see a lot of D1s, D2s, all sorts of things, and it might be a little bit confusing what's what. So I also like to rename my dimensions. So let's see here. I think this dimension, yeah, this represents the number of instances in the slot pattern. So this upper field is the dimension name. I'm going to change it from D1 to just call it the slot number. So whatever you want it to be. What's really nice about equation renaming is you can do this after the fact. If you've already gone in and written your equations, excuse me, I meant dimension renaming, SolidWorks will automatically update everything for you. So we'll call this the whole number. So now I want to create an equation. Links the slot number to the whole number. I could do it in the graphics window through dimension modify. I could also do it by editing my equation. So I'll right click on the equation manager, say manage equations, and we can see a number of additional equations have been populated through changing the dimensions and linking them to the fillet's global variable. But this one's going to be very simple. The dependent variable is the number in the slots. The independent variable is the whole number. As easy as that. Now, I need to be careful because it's set up right now to only be evaluated in this configuration. If you remember back from the PowerPoint, equations are configurable as well. So it does behoove you to slow down and kind of double check your work. I tend to get in a hurry, tends to cause problems. So I'm going to set this to all configurations, and we'll say rebuild, okay. And now let's test the part. So we'll go to 5 holes, looks good. 6 holes, looks good. And now everything is automatically updating. So at least we have the number of slots matching the number of holes. But maybe it's not quite good enough. I want to point something else out here with this model. Notice the position of this curved slot. It's static. It doesn't move. Well, I would like it to stay centered with respect to all of the bolt holes. I didn't create it that way. I've got this static dimension in there. Instead of recreating everything, I could get it to work exactly the way that I want it to work using an additional equation. So let's go ahead and set that up. I'm going to make the equation within the dimension modify box just to show you, the different ways. So instead of it being evaluated at 30, we'll hit equal. That'll get us into equation writing mode. And even though the parentheses aren't necessary, I'll go ahead and type them in because you might need to have parentheses to control the order of operations. So we'll say, 360 degrees in a circle divided by the number of the bolt pattern, and then we'll just divide that by 2. Just like the other equations, I want it evaluated in all of my configurations. And once I rebuild, you can see the positional change of that curved slot. So let's test again. There's 5 holes, 6 holes, and 7 holes. And we don't have a lot of geometry left over between the holes or the slot and the little bolt pads, but you can see we're starting to build some logic into the part. It's doing what we want it to do without having to start over, scrap everything that we've done. So a final example for configurations, or equations in this case. Let's talk about the overall outer diameter. Maybe we would go through a further process of making various configurations with different outer diameters. And we would do that the same way. So I'm not going to go through that process. But it could go up to maybe 250 millimeters. Maybe it could go down to 180 millimeters. We can see if we get too small, we may run out of geometry where those curved slots exist. Just to, I'll say, force the issue, if we go down to 175, things start to overlap. Now, wouldn't it be nice if we could shut these features off automatically based on this diameter right here? Well, thankfully, it's pretty easy to do with the new, I say new, but it's been around for a couple of releases, the if statement inside of our equations. So let's go ahead and set one of these up. We'll right click and manage the equations. And this really works. It works for both feature suppression as well as dimensional values. I'm going to start off with feature suppression here. So we'll make sure you select features. If you don't have your mouse in there, it doesn't really do anything. So I'll select the cut slot. And the function, you can see various trigonometric functions. Clear down at the bottom is the if statement. So the if statement will be driven by this diameter right here, so we'll just left click to select it. And it's going to be fairly simple. Let's say if this value is ever less than 190 millimeters, or whatever we want, we'll put in a comma there, suppress, and really all you need to do is say SU or S, and SolidWorks will give you the option for suppressed. And another space, comma, space, unsuppressed. In this case, I only got to U. I'll just space this out so you can see it. So there's the code for this equation. If the outer diameter gets less than 190, suppress the feature, in this case the cut slot, otherwise unsuppress it. Same thing. Double check which configuration it's evaluated in. I want it in all configurations. So let's test it. Let's go down to 185 and rebuild. They automatically suppress, excuse me. You can see slot cut, slot pattern, they're gone. Let's change it back to 200. Well, that's a little bit strange because only the slot cut is unsuppressed. Well, the reason for this behavior is parent-child relationships in SolidWorks. I'm only controlling the slot cut in my equation. But once the parent feature is suppressed, the child feature of the pattern has to be suppressed as well. Well, that's not true going the other way. The parent can be unsuppressed and the child can still be suppressed, and that's what's happening here. So I do need one additional equation. So we'll go back in and we'll manage the equations. Now, one interesting thing I found is you can actually copy and paste your equations, but it's not very straightforward. The first thing you need to do is just select everything. So do this before you start to write your new equation. So I want to copy everything for my if statement. And there is no right-click copy, so just Control C to copy it to the clipboard. Now we can go to the next feature cell, select the slot pattern, and be careful because it will automatically put in an equal symbol, and I copied the equal symbol from the above equation. So I'll delete that, and now we'll Control V. So if you have a complex equation, you can easily copy and paste. Just remember, copy first, Control C, Control V. There's no right-click edit, right-click copy here. And as soon as I put it in there and hit enter, they're automatically unsuppressed. So let's test this equation with the second if statement in there. So we'll go down to 190 and rebuild. It's still there. Let's go to 189, rebuild. It's gone. So you can see, pretty cool. You can start building some logic into your parts, and you can have as many if statements as you need, and you can really get some very complex behavior, some really nice automation, all within inside of SolidWorks. So now we have a part that is definitely closer to that $6 million part. It's much more robust. Things automatically update. One dimension kind of trickles through everything. It's the way that I wanted it to be. It's not necessarily the way that I started though, but I was able to get there by setting up a couple of equations to automate everything, and then that gives me the flexibility through my configurations. So we've got everything linked. The number of slots matched to the number of holes, automatically centering the slot, if statements when we need them, global variable to control the fillets. And the important thing, it rebuilds correctly and we didn't have to start over. That's what I want to emphasize here. So some final thoughts with equations and configurations. I like to rename my features and my dimensions. Helps me keep everything clear when I'm writing a lot of equations. After you've set up your equations and you're making changes to the dimension modify window, watch this window. Remember, every single dimension will be set to all configurations. You cannot control this for the entire part. So I've found a couple enhancement request numbers that would give us the ability to redefine this setting for the entire part, for example. So I recommend log in your customer portal account. Please do this. Find these enhancement requests and vote for them. That's how changes, are implemented inside of SolidWorks. Definitely test for rebuild errors. Equations and configurations are just changing the dimensional values, so you need to make sure that your part is robust enough. Start slow, add complexity when you need it, and have a plan. It's not a bad idea, in my opinion, to write things down. What do you want the part to do? How do you want to automate it? And then you can go tackle the dimensions and set up your equations and your configurations accordingly. So thank you very much for your time. I really appreciate it. If you have any questions about this presentation, don't hesitate to send an email, support@mcad.com. Just mention you have some equation and configuration questions from the Tech Day presentation. They'll get routed accordingly. So thank you. Have a nice day.